I'm going to be solving 3.3. It's asking which could be used to prepare soluble salts. Bases don't really react with anything to give you salts. Acids are the ones that usually react with something to neutralize it. It could react with a metal to give you a salt and hydrogen gas, for example. But bases don't really react with stuff that way. Preparation of solid salts involves direct combination of two elements. Yeah, it's precipitation. You get two aqueous solutions and you mix them. And obviously a metal goes from one of the solutions and a non-metal goes from the other, and then they make an insoluble solid. Here you can tell because it has every ion. Like these two are the same. They could be cancelled out, but it's the main way you can tell is that it has every ion. If you see two of them on different sides, like you see K here and you see K here, then it's overall. This one, there's no ions at all. All of the compounds, they're not separated like here. So it's non-ionic. Net ionic means you just cancel out whatever you can. So you see you cancel out NO3, NO3, K and K. HCl reacts with K2CO3 to give a salt, a liquid, and a gas. So the way you can tell, you take the acid, which is HCl, and you take whatever you're reacting with, in this case K2CO3, take the cation from here and the anion from the acid. So it becomes KCl. Potassium chloride, KCl. Give the chemical formula for the gas. It's a carbonate. Acid plus metal carbonate. An acid plus a metal carbonate gives you a salt, which is this one, plus water, which is the liquid, plus CO2 gas. Always have to memorize this. It's carbon dioxide and it gives you CO2. Here they said the net ionic. The way I did it, which it takes a lot of time. If you have time in the exam and you're confident you can do it, you don't have to, but it's just the way it works. So you have 2H plus it was HCl, yeah, so plus 2Cl minus plus 2K plus CO3 2 minus gives you 2H plus. It gives you 2KCl, but because it's overall ionic, I'm just doing the overall ionic to show you. It splits up again, plus CO2 gas, it's not an ion, see, plus H2O liquid. You just cancel out whatever is in common. Oh, sorry, not doesn't give you 2H plus, because the H plus turns into water. That's how you have H2O. Cancel out whatever you find in common. So Cl here, Cl there, K here, K there. Just cancel them all out, and you write whatever you have left. So it's 2H plus CO3 2 minus gives you CO2 plus H2O. And also, if you look at it, it makes sense, because look, it gives one of its O's, so it becomes H2O. And also an O is 2 minus, yeah? CO2 doesn't have a charge, and O is 2 minus. And here it's 2 plus. So it evens out, it becomes water. And then it just turns into CO2 gas. Again, to find the salt, you do the same thing. So H2SO4 and Na2O3. take here Na, oh, wait. You take here the Na, take here the SO4, Na2SO4. And you keep it Na2 because it's SO4 2 minus. Same with SO3. Okay. So here it's Na2SO4 and sodium sulfate. Give the name and the chemical formula for the gas. By the way, if you do this and you get it wrong, it doesn't accept capital letters. I don't know why. I did. It doesn't accept capital letters. And then you have to remember this too. When metal sulfite, SO3, there's three things for sulfur. You have SO4, which is sulfate. You have SO3, which is sulfite. And you have S2 minus. All of them are 2 minus. And you have S, which is sulfide with a D. This one doesn't react with acids. It just doesn't react because it's already a salt. This one, when you react it with a gas, or you react it with an acid, which happens now, you get salt plus water, like any other reaction, but you also get sulfur dioxide, SO2 gas. And with this one, you get, I forgot the name of the gas, but it's H2S. I think it's sulfur hydride maybe, but it's H2S definitely. When you react when you react a metal sulfide and an acid, you don't get water, you just get a salt plus H2S. These are all here in the book. All of the reactions are here, see? React this with this, react, see? Hydrogen sulfide, yeah, my bad. So after you get that, then after you get this, we already got it. So it's when you react an acid here with a sulfite, you get sulfur dioxide gas, SO2. And then here, right, again the net ionic. So do the exact same thing like last time. So it was 2H plus SO4 2 minus plus Na plus 2 Na plus SO3 2 minus gives you SO2 gas plus H2O plus 2Na plus SO4 2 minus. Cancel. This is what you have left. You have 2H plus SO3 2 minus gives you SO2. It's the exact same thing like last time. You just take one of the O's, you give it here, it evens out both of them. So here they tricked you, because you're gonna think, oh, it's a base this time, so it's gonna be different. No, because the thing is, you have to remember, ammonium is a weak acid. It's barely mentioned. I don't know why, but here it's also in the book. When you react a base with ammonium salt, that's what you get. So you have to remember, it's not like it's the exact same as the other question. It's not different. Because maybe, for example, someone will say, oh, this is, you take the anion from here and no, it's not NH4OH. This is the acid and this is the base. So NH4NO3 and KOH, here, you take the K from here and the NO3 from here. Because they're both +1. You don't need the subscript or anything. It's potassium nitrate. The gas is ammonia, NH3. You have to remember what every reaction gives you. So when you react an ammonium salt with a base, you get salt plus water plus NH3. Most of the time you can easily tell what a reaction gives you. Like acid plus whatever usually most of the time gives you salt plus water plus maybe something else. Not all the time it's something else. And sometimes it's just for the sulfide, so for S2 minus, and for just a metal by itself, like for example Mg, you're not gonna get water, you're only gonna get these two. You're gonna get, for this one, you're gonna get hydrogen gas, for this one you're gonna get H2S. You have to remember what everything gives you. And then here you have to read the question. Balanced net ionic equation, again, because the next one says balanced overall non-ionic. Always read the question though. Again, you can do the same thing like last time, but sure you guys get the idea by now. You separate all of them. So it's NH4 plus NO3 minus plus K plus, so OH minus gives NH3 gas plus H2O plus plus K plus NO3 minus. Okay, look, remember how I said last time you just take the O from the other one? Here, that's exactly how you get water this time, but instead of taking an O, you take an H. So you see here, it's OH. If you look here, these two are reacting. So if you give one of the O's, it's gonna go back to normal. You're gonna really, if you give one of the H's, sorry, you're gonna you're gonna get rid of one H, so it becomes 3, and the charge is gone because it was the way you get ammonium is with this, and you react it with the H plus. So when you get rid of the H plus, it just becomes NH3 again, and the H goes here, so because H plus balances out the charge and it gives you H2. Then you just cancel. So cancel. NH4 plus OH minus gives you H2O plus NH3 gas. It's just the repeat question. Just this time they're not gonna ask you for a gas because no gas is formed. When it's with a base or a metal oxide or a metal hydroxide, so metal hydroxide, you don't get a gas with it. It's just salt plus water. You're always gonna get a salt when you react something with an acid. Always, doesn't matter what. It's just the other stuff you have to memorize. And usually it's just water and the gas, and you can tell the gas from the whatever you're reacting with. There are just 2 exceptions where you don't get water, which is, like I said last time, sulfide and with just a normal metal like MgCa. You just get H2 gas plus whatever salt. Here, see, so you're just reacting a metal hydroxide with an acid, so you get salt and water. That's it. See, the base. Anything that ends with OH is a base. This is like under both metal hydroxide and base. So you have a base plus acid gives you this salt plus water. Okay. Read the question carefully. So here they want, how do you get soluble magnesium chloride? Always read if it's soluble or insoluble. It's gonna help you so much. You're gonna find out why now. To prepare soluble salt magnesium chloride from the insoluble base magnesium oxide. So that means you have MgO now. You're trying to get MgCl2. This one is solid and this one is aqueous. How do you get it? With a burette and an indicator, you use it when you have a soluble base and a soluble acid. So you have base, usually it's the base in here, in the burette. Usually it's a base in the burette, and then base. Then you have an acid and an indicator, like the methyl orange, that type of stuff. But they both have to be soluble, or else what? Like, it's not even gonna go in the burette if it's insoluble, so it doesn't make sense. Mixing two solutions to obtain a salt by precipitation. This is when you want to get an insoluble salt. You already have one. The way precipitation works, you have two aqueous solutions, and you mix them to get something, a precipitate. This one makes sense. Look, you add an excess base or metal, so it's an excess base, to a dilute acid. We don't know which acid yet, ignore this for a second. And you remove the excess by filtration. Filtration with the funnel paper filtering. So this is the only one that makes sense, because you have something insoluble, you're trying to get something soluble. Then they're asking what reagent is used, so which acid is used. This is how you can tell also. So you have MgO, and you get MgCl. It's plus an acid, so plus H something. Plus H something gives you MgCl plus H2O. What else can it be other than HCl? And then you just write it out, plus H2O, because remember, it's a base plus an acid. To obtain ZnSO4 solid, when H2SO4 reacts with ZnO is crystalline. Here's the thing. Even I got it wrong the first time, but because you're gonna think, oh, you're trying to get a solid, it's gonna be precipitation. But no, because remember the exceptions for SO4, the solubility rules. It's soluble with everything except for calcium, barium, strontium, lead. Capacitor and lead, that's how I memorized. Zinc isn't any of them, so it's soluble. So how do you get a solid from something soluble? You crystallize it. So it's just the same as acid with base. So this is how it works. So ZnO plus H2SO4 is gonna give you ZnSO4 plus H2O. All of them are, I'm not sure about this one, but all of these are aqueous. How do you get something solid from something aqueous? Crystallization. Or evaporation is also accepted. So you're mixing ammonium salt with a base. What do you get? You get a salt. I'm not gonna complicate it too much. You get a salt plus a water plus NH3 gas or ammonia gas. Remember the difference between ammonium and ammonia. Ammonium is NH4 plus and ammonia is just the gas. Ammonia is, out of all the gases we took, it's the only basic one. So if you put any other gas, for example, that when we took, I think it was topic 11, I might be wrong, with the testing, when you add an acid to CO3 and you get CO2, all of them, the reason you can't use a litmus paper is because all of them are going to turn it red, except for ammonia. So it makes go from red to blue, and it's ammonia gas. You should know from the reaction. To prepare PbSO4, equal quantities. Look, I can't open all of the options, but I remember one of them. Look, I remember this one, it was PbCl and also PbCl2, PbOH2. Okay? Again, you always have to remember what's soluble with what you have. These rules, we took them before we took them. It came in our periodic last time, but you always have to remember them till now. So again, halides are soluble with everything except for Ag plus, Cu plus, and Pb2 plus. Everything. And hydroxides are insoluble except for Ba plus and Ba2 plus and Sr2 plus. This isn't Ba or Sr, so it's insoluble, and this is Pb, so it's insoluble. The way you do precipitation, like I explained last time, it was you mix two aqueous solutions. Because if you mix one of them, it's a solid here, obviously it's not going to react. You're trying to get something insoluble. Also same here. So you get something. The way you can tell is because SO4. The other two options were SR, SO4, and BaSO4. The reason that doesn't work, again, Ca2 plus, Ba2 plus, Sr2 plus, Pb2 plus. You want two soluble things. So to get SO4, obviously this one has to have SO4 and it has to be soluble. So Na is the only option. So one has to have Pb and it has to be soluble. This one's the only option. This one is the only option. So insoluble salts are prepared by precipitation.